Hi, I'm Jack Jellies, and in the video that I'm making today, I wanted to share a little bit about the adventures I've been having with my do-it-yourself pneumatic engraver. I enjoy engraving as a hobby, and I've done a few years worth of it. I'm not going to spend a lot of time talking about the process today or the details because I wanted to concentrate on the tool that I built and share with you my understanding of pneumatic engravers and why I really enjoy using them. In brief, engraving metal is an ancient art where you use a hardened piece of metal. In this case, it's called a graver that has a particular shape, and it's a sharp bit here, and you push it through the metal surface and you carve the metal much like you would carve wood or soap or anything like that. There are dozens and dozens of different details that one needs to be aware of when you think about the materials that the gravers are made out of, how to sharpen them, how to maintain them, how to shape them. And there are literally hundreds of different profiles for different tasks. So that's well beyond what I'm going to do today. Now you can imagine though that this is a process that's really just a manipulation by hand in order to make designs in a metal surface. It's very similar to the process of wood carving, which I also do, but the chisels would look a little different. Here's an example of a wood carving chisel that happens to be beveled just on one side. So it's a very sharp tool with a profile that will control the shape of the wood chip that's come out. And you do this the same way. I'll make a little clip of the wood carving tools in just a moment. And of course you compare that and contrast it with stone carving, which I also like to do. And here's an example of a stone carving chisel. And of course, to carve stone, because that material is so hard, it would be probably not very effective to take this by hand and try to push it through the stone. So typically we use a hammer at the end of this to beat against the stone and carve chips of stone away. So what we've done with the engraving tools is to generate a set of tools that does the same kind of thing as using a hammer to help push at the end or touch at the end to impart a little kinetic energy to help us move these tools through the metal. So that's what I want to talk to you about today in this video. I hope you enjoy it. So when I carve wood, there's an analogous process that you use for engraving, and I just thought I'd make a mention of it because it might help people understand the engraving metal a little better. There's mostly these chisels that are used to remove wood, and the chisels are metal, they're hardened, and they have different shapes to cut out different profiles of metal or wood chips. You'll notice they're sharpened by beveling on one side only, and that's so that you can dig in to the wood and remove it in a chip. Now, when you use a handheld tool like this, it's called push carving because you're just pushing, using your hand pressure, the tool through the wood. But a lot of times you either want to take out a little more wood or you need better control. And so what you do there is called a hammer and chisel. So you use a larger wood chisel like this one with a more substantial back, and you'd control the tool with one hand, and then you'd use a hammer, in this case a wooden mallet, to force the tip of the tool through the wood. And now what you're doing is you're using your one hand to control both the angle of attack and the angle that you are curving around the wood in, and this is being used, the other hand is being used to provide a little bit of the pressure to get the tool moving through the wood. Now there are also then motorized bits that instead of using a handheld hammer, they use a rotary tool that's going to beat against the back of the tool, or there are Dremel tools which instead of using a sharp chisel will use a bit that kind of grinds away the material. There's a variety of things like that that are similar. So we have similar things going on in metal engraving. The most typical thing to do is to use an engraver in your hand, and it's called hand pushing. And then you can use a hammer and chisel to engrave. But you can imagine that what happens is if you're going to do really small things like jewelry pieces and things under the microscope, it might be handy to have something that was like a hammer and chisel, but that you could hold in a tiny profile in one hand. And that's the real advantage to these pneumatic engravers. They are still these hand pieces that are guided by hand. It's hand engraving, but it's really a small powered hammer that's giving you little taps at the back of the graver tool. Anyway, I thought that was a reasonable way to begin explaining why I like to use a pneumatic engraver. So, the handpiece, how does it start? Well, taking tip from Rick Alexander on YouTube, what I did was I started with one of these stainless steel bolts, and it's a good source, good size, and cut the head off and trim it. You wind up with a chunk like this, about 2 inches long, and then putting that in the lathe, you can clean up the faces, the ends, and then drill holes to hold. In this case, you hold the engraver chuck, and in this case, I would be drilling, that's the pilot hole, I'd drill a slightly larger hole that would hold the piston. So what it would end up looking like then is this. And of course, you have to drill some vent holes, like there, that goes straight through. And then you drill a set screw hole to hold the collet in. And of course the handle I made out of Delrin, and to make that, that's a plastic, and I just have a chunk of 1.25" Delrin, cut about 1.5 inches of that off, 2 inches of that off, and turn it to a shape that you like. Drill a hole in one side, tap it for the threads on the bolt, which are 20 pitch. They're called a fine thread, and that gives you the ability to turn that and turn it off and on. Now this handpiece, what happens is if you unscrew the handle, you then can see that it's hollow, and what I've done is I've put a spring in there, and then I have a piston that I turned from a piece of stainless bolt. It has a couple of detents on it, and that slides right in there. So you put that in there, you put a spring behind it, and this nut helps you tighten up on the handle to position the handle so that you can mechanically tune the back and forth movement of the piston depending upon the pressure and the frequency of the pressure pulses that you're getting. Now notice what happens is if I put the graver tip, this is the business end of the graver that I'm holding in a collet, that will fit right into the end of this, ideally. But will if I turn the set screw out. Whoops. Okay. Pick up my spring, put the spring back in there. What you'll notice is that the piston hits the collet right there at the vent hole. The collet comes right to the vent hole, and then the piston will whack into it, driven by the pressure pulses from the air compressor that you've modified. Okay, so what happens is when you put pulses of air, positive and negative pressure through here, when it does negative pressure or sucks a vacuum, it pulls that piston back this way, and it compresses that spring capturing some of the kinetic energy from the vacuum. And then when the pressure reverses and it pushes the piston, the spring adds its little bit of energy to the piston and it whacks hard into the back end of that graver. And that's what gives you the impulsing that you need to push this through the metal. The action of the piston pretty well if I hold up the handpiece to the window, and as I suck on the tube, you'll see the hammer, the piston rise, and then I'll blow and it'll fall. And they meet right at the middle of the vent hole. So if you drill these holes with just the right dimensions, it makes it possible to tune this thing mechanically so that it's like pushing a swing, and you get a really nice rhythm going so that you can hammer against the graver. So the way that I put this thing together to make it functional was to assemble the pieces that are controlling the positive and negative pressure pulses inside of a cheap toolbox with a lighted switch that turns it and a fan on. So there's a fan here that helps cool the compressor inside. And then there's a potentiometer which allows you to adjust the speed of the motor. And typically, you're going to be running it at less than 50%. And then this is driven by a foot pedal, which is down here. And the foot pedal is just a pneumatic where if you're not depressing the foot pedal, then it's venting all of this air. But if you depress the foot pedal, the air is diverted to the handpiece, and that starts the piston moving back and forth. So that's a really, really good way to control it. Now, if I were to open up the box, you can see that it's a pretty simple device here. All it is you need to do, all you need is a device that's going to push air back and forth. So to do that, courtesy of Sean Hughes on YouTube, I modified this very inexpensive tire inflator, and you modify the piston so that it is not compressing air, but every time the piston goes up, it's pushing air out of the tube, and then when the piston goes down, it's pulling the air back in through the same tube. So that's all you really need. These other boxes are just there to provide power to power this 12-volt motor. So this is a 12-volt DC power supply that I purchased. It's generally used for powering LED strips. And then to regulate the speed of this and to regulate the current that's going to the device, I use a pulse width modulation control. So what this does is it's going to produce pulses of output, of voltage output, and depending upon the frequency and the duration of those pulses, it's going to control how much total current is actually felt by the motor. And that's a way to control the speed of the motor without affecting the torque of the motor very much. So it's a pretty simple device, really. And all this together costs about, let's see, 35, 10, and probably 15. So, less than 50 bucks for those parts. Maybe 60 bucks if you think about it. And then some wiring and a switch, and that's about all there is to it. Now, you can get fancy with how you want to put this in a box, but I just decided for this prototype to do something pretty straightforward and simple. So, apologize for the wiggliness of this. This is just mounted my phone on the tripod on the bench. So what I'll do is now try to cut a piece of steel here to show you how this tool works.
see the little coil of metal that's being carved right out of the steel. This thing works surprisingly well for such a simple design. It won't replace my Lindsay classic handpiece, but on the other hand, it's pretty cool to have a tool that you make yourself, and it allows you to do things that would otherwise be pretty difficult to do.
Not a very good scroll, but yeah, pretty cool. You can see this actually move under the microscope. So if I were to go a straight line, let's do a little straight line here. This steel practice plate is a little harder than I like, but it's kind of fun anyway. Just do a little angle. There, can angle that out, make a little comma. Let me compare that for a moment to my Lindsay. I'll turn on the compressor for the Lindsay, and it too is foot pedal driven. And now you can hear that probably. It's much quieter, but this is a different handpiece. There, you can see this is the much faster, much smoother. You can see why I really love this Lindsay handpiece. Steve Lindsay makes these. He's a very, very talented man, great artist. And of course, it costs 14 times what my homemade engraver costs, but it does a really, really fine job. So I really, really do like this commercially available engraver. But I really wanted to see what would happen if I made my own tool. And it is handy to have a tool that works more slowly than this one. Yeah, so that's the Lindsay.